Hello students, it is the fifth part of the series of important questions of IOQJS. It is from heat, that is calorimetry and thermal expansion. Now question start करें. It is the question number 1. For a 5 gram substance, the heat supplied in calories and temperature in degrees Celsius curve is given below. Then the specific heat of the substance for liquid state will be, we have to find the specific heat for liquid state. Think about this temperature, minus 10 degrees Celsius, 0 degrees Celsius and 100 degrees Celsius. This is the part, it shows liquid state, this shows liquid plus solid. So we have to calculate only this part, that is A to B. From A to B, at x-axis heat supplied, we can easily find that is Q. So heat supplied, that is Q is equals to 220 minus 120, 220 minus 120, that is equals to 100, that is in calories, calorie. Okay, temperature is from 0 to 100, change in temperature, that is equal to 100 minus 0, that is 100 degree Celsius. We have to find the specific heat S. Mass is given, that is 5 gram. So we can easily find Q is ms delta T. Delta T means temperature, change in temperature. So S will be equals to Q upon m delta T. Q is 100 divided by 5 gram into 100, that is 1 by 5. We can say S will be equals to 0.2 calorie per gram, because mass is taken into gram into degree Celsius. So it is the answer. Correct option is that's B. It is the solution of question number 1. Next, second question, if T temperature, T represents the absolute temperature of an ideal gas, the volume coefficient of thermal expansion at constant pressure is, first of all, what is volume expansion, coefficient of volume expansion? आपने किया होगा अल्फा, बीटा एंड गामा इज गिवन बाई डेल्टा वी, चेंज इन वॉल्यूम डिवाइड बाई वॉल्यूम इनटू चेंज इन टेम्परेचर, इट इज अल्फा, बीटा, गामा. So now think about it. For ideal gas, we know that PV is equals to nRT. In chemistry, you know very well, T is absolute temperature. Okay, if B, it is given, that is pressure is constant, so P is constant. If we change V, on changing V, T will change, or we can say on changing T, V will change. So that is P into delta V, that will be equal to N into R into delta T. We can easily find P delta V divided by delta T, that will be equals to NR. It is first, it is second. अब देखिए from first we can easily find the value of NR. From first, what is the value of NR? That will be PV by T, put here. So it is gamma, P delta V divided by delta T is equals to PV by gamma, PV upon T, P cancel, and delta V by V into delta T, that equals to 1 upon T. It is gamma. Required answer. So our answer is the volume coefficient of thermal expansion at constant pressure is constant. So answer is, it is the correct answer, C option. Now the third question, next question is, it is the third question. A wire of length L 1 centimeter and a Q of side 1 centimeter, same, it is the wire, L is equals to 1 centimeter, it is Q having side 1 centimeter, 1 cm, also 1 centimeter cube. 1 centimeter of same material heated by 1 degree Celsius, mean delta T change in temperature also 1 degree Celsius is given. Change in length of the wire is x, then the change in volume, we know that in linear expansion change in length delta L is L into alpha delta T, L alpha delta T, change in length is given, that is how much, x is equals to L is also given 1 into alpha into delta T is 1, so what is the value of alpha, that is x. Now think about the volume, superficial expansion or aerial expansion, we know that the delta superficial means we have to find the value, sorry, volume. Volume means we have to calculate okay superficial, linear volume is volume expansion that is delta V, we have to find the volume not aerial, delta V is V into B, that is gamma, or delta T, V gamma delta T, V delta that is V is equals to volume of this, that is 1 into 1 into 1, delta T also 1, then we can also write delta V is equals to 1 only gamma. What we know very well, relation between alpha, beta and gamma is 3 times alpha, so we can write delta V is 3 times alpha, or alpha is given, it is, put this value here, so delta V is, that is 3 times x, change in volume is 3x, so correct answer is change in volume is 3x centimeter cube, it is the change in volume. Next question is fourth, the temperature of a metal coin is increased by 100 degree Celsius and its diameter increases by 0.15%, its area increased nearly, okay, diameter linear, we can say delta D is equals to D into, that is alpha delta T, delta D is change in diameter, delta D is change in diameter, okay, that is delta D change in diameter, D is diameter, so we can write from here delta D divided by D, that is equal to alpha delta T, if we find delta D upon D percent, that is equal to alpha delta T percent, that will be equal to given 0.15%, it is given. What we have to find the area increased nearly by superficial expansion, delta A change in area is equals to A initial, that is 2D, so beta delta T, we know very well beta is 2 times alpha, so delta A upon A, that equals to beta means 2 alpha delta T, we have to find the percent change, so delta A upon A percent, that will 2 times alpha delta T, it is percent, it is given from here, it is how much, 0.15, so it is 2 into 0.15, that is how much, 0.15, 3%, it is delta A by A in percent. So percent change in area is 0.3%. Correct option is C. This was the question number 4th. Now the next question, it is 5th question. 5th question is, two identical blocks of metal are at 20 degrees Celsius and 80 degrees Celsius. First metal is at 20, second is at 80 degrees Celsius respectively. The specific heat of the metals of the two blocks increases with temperature, means specific heat of first and second, they are different, they depends on temperature. We can say suppose the specific heat of at 20 degrees Celsius, that is S1, at 80 is S2, then definitely S2 is greater than S1, okay, with temperature. Which of the following true about the final temperature Tf when the two blocks are brought into contact, assuming that no heat is lost from the surroundings. So देखिए, now the solution. Final, suppose given final temperature is Tf, so it is confirmed 20 is less than Tf, but Tf is less than 80 degrees Celsius. Specific heat at 20 degrees Celsius is S1 and at 80 degrees Celsius substance is S2, then definitely S2 is greater than S1, depends on temperature. Now when they are placed in contact, then the heat from the second body will transfer to the first body. So when placed in contact, then heat taken is equals to heat given. So heat given due to the body which is at high temperature at 80 degrees Celsius, and heat taken due to the body first body which is at lower temperature, that is 20 degrees Celsius. Now think about heat taken by the first body, so its mass is same, it is given m. Specific heat, identical bodies, mass is same, so m specific heat is S1 into temperature from 20 to Tf, so Tf is greater than Tf minus 20, that will be equals to heat given by the second body, so mass is same, specific heat S2 is clear, and its temperature decreases from 80 to Tf, so 80 minus Tf, Tf is the final temperature, m cancel, we can easily find S2 by S1. So from here देखिए S2 by S1, from here S2 by S1, that is Tf minus 20 divided by 80 minus Tf. Again Tf S2 by S1 equal to Tf minus 20 divided by 80 minus Tf. We know very well it is 1. We know very well because S2 is greater than S1, so we can write Tf minus 20 upon 80 minus Tf is greater than 1, because S2 is greater than S1, so Tf minus 20 that greater than 80 minus Tf, transfer Tf towards here and 20 here, that is 2 Tf is greater than 800 or Tf is greater than 50 degrees Celsius. It must be the answer, it must be the answer. So correct option is Tf will be 50 degrees Celsius, Tf will be more than, so correct option is B. The important question, you can write here most important for the point view of IOQJS part first. Okay, it was the question number 5th. Now the question number 7, 5th, now question number 6th. 6th question, a new temperature scale uses x as a unit of temperature where the numerical value of the temperature Tx in this scale is related to the absolute temperature T is given. Tx that is equal to 3T plus 300. Okay, the specific heat of numerical of the material using this unit means in this unit is 1400 joule per kilogram and Kelvin to the power minus 1. It is given. Specific heat know very well. S in X is Q upon M delta Tx. It is given 1400 according to the question, 1400 joule per kilogram into Kelvin. It is given in question. In SI देखिए, in SI specific heat in SI it must be equals to Q is same upon M is same, here is delta T. It will be the answer. We have to find the value as specific heat in SI system. So we want to remove this delta T with the help of this relation. Think about it. If we change Tx, then definitely T will change. There will be no change in T under 300. So we can delta Tx that will equal to delta T plus 0 3 times, that is into 3. The value of Tx is 3 times delta T. So from here what is the delta T? Delta T will be equals to delta Tx divided by 3. On putting this value here, we can easily find specific heat in SI will is equals to Q upon M, or the value of delta T is delta Tx divided by 3 means 3. It is given 1400 into 3, that is how much? 4200. It is the answer. Joule per kilogram into Kelvin. That is correct answer is 4200 joule per kilogram into Kelvin. It is also important question. Note these questions. जहाँ मैंने important लिखा है, actually they are most important for IOQJS. It was the question number 6. Now the next question is 7th. 7th question is, if temperature of a certain mass of aluminium having a specific heat, so specific heat S is given, that is 0.8 joule per gram, 0.8 joule per gram into degree Celsius. It is given in question. Now is lowered by 6 degree Celsius, change in temperature is also given. Change in temperature, that is delta T, is 6 degree Celsius. Heat lost means that is Q is equal to 96 joule. क्या find करना है? Find the mass of the aluminium. We know the relation very well. Q is M S delta T. So what is M? Q upon S delta T. Q is 96, S is 0.8 or delta T is 6. We can easily find. Now solve it. 6 one time, or that is 6 time. It is 160 divided by 0.8. You cancel, that is 160 by 8. That is how much? 20 degree Celsius, 20 gram. It is the mass. The mass. So mass is, that is how much? 20. It is the answer. So answer is, correct answer is D. It is the IJSO stage 1 2013 का question है. Is it clear? Now the next question is 8th. This is the question. an aluminium piece of mass 50 gram initially at, first of all remember to when you are solving the question, जब आप question solve कर रहे हैं तो use only one system, either CGS और SI. गलती के चांसेस यहाँ ज़्यादा रहते हैं. फॉर एग्जाम्पल देखिए, इट इज गिवन इन ग्राम, ओके, बट हियर इज गिवन किलोग्राम, SI, तो मिस्टेक के चांसेस यहाँ बहुत ज़्यादा हैं. तो देखिए, एन एल्यूमिनियम पीस ऑफ मास, तो मास ऑफ एल्यूमिनियम AL is that is 50 gram. We can convert is 50 into 10 raised to the power minus 3 kilogram. Okay, initial temperature is this, is dipped quickly and taken out 1 kilogram water. Mass of water is not given in kilogram, it is in gram, it is 1 kilogram. So convert in SI all the quantities. Initial temperature 30 degrees Celsius. Initial temperature of water is 30 degrees Celsius. Temperature of water is 30 degrees Celsius. It is 30. Okay. Aluminium piece 160. If the temperature of the aluminium piece 160, what the temperature of water is, specific heat of aluminium is given, also that of water is given. So when the aluminium piece is dipped in water, then heat is taken by water and heat is given by aluminium. So change in temperature for aluminium delta T is given how much? 300 minus 160. Final temperature is this, or initial temperature is 300. We have to find the temperature of water. Suppose temperature of water is theta. When the aluminium piece is dipped in water, then heat taken by water is equals to heat given by aluminium must be equal by the law of mixture. So mass of water is 1, specific heat 4200 and its temperature 30 से increase होगा, तो हमने किया थीटा माइनस 30 degree, that will be heat given by aluminium. The mass of aluminium is 50 into 10 raised to the power minus 3, it is given in 900. Specific heat, it is 900 into 900 into change in temperature is given, this one, that is how much? 140. We have to calculate theta. कर सकते हैं आप easily, this cancel, okay, then theta minus 30 degree, that will be equals to that is 1 and 2 70, that is 10 raised to the power minus 1, it is, and theta minus 30, that will be equals to 5 into 9 into 14 into 10 raised to the power minus 1 divided by, and that is 42. Here 3 time, that is how much? 1.5. Theta minus 30 is 1.5, so we can easily find what is theta. 30 plus 1.5, that is 31.5 degree Celsius. It is the answer. The final temperature of water is 31.5 degree Celsius. Correct option is C. Is it clear? Now it was the question number 8. Now the question number 9. The coefficient of linear thermal expansion, that is alpha. Alpha is given is 11 into 10 raised to the power minus 6 per degree Celsius. If the percent change in the length of the rod when the temperature changes by 70 degree, change in temperature is 70 degree Celsius, you have to find the percent change in length. percent change in length, we know very well change in length, that is delta L is equals to initial length L alpha delta T. All things are given, delta L upon L, that is equal to alpha delta T. Alpha is 11 into 10 raised to the power minus 6, delta T change in temperature is 70, L alpha into delta T. We have to find the percent change, so delta L upon L percent multiplied by 100, 11 into 10 raised to the power minus 6 into 70 into 100, it is 77 into 77, 1 2 3 minus 3, that is how much, 0.077% is the change in delta L upon L, percent change in length. So correct answer is A, 0.077% is the change in length. It was the question number 9. The next question is 10th. Okay, a copper disc of radius A naught has a hole of radius B naught at the center at 0 degrees Celsius. The disc is now heated and mentioned at 200 degrees Celsius. The new radii of the disc and the hole are AT and BT respectively. For the heated disc, it can be concluded that, first of all, think, most important, it is the disc, okay, it is the hole, it is the material, it is the material. On heating everything will डायमेंशन की बात कर रहा हूं, हर डायमेंशन इंक्रीज होगा. अब मैं बात करूं फ्रॉम ए टू बी, ए बी इंक्रीज होगा, बी टू सी भी इंक्रीज होगा, सी टू डी भी इंक्रीज होगा. देखिए ए बी इंक्रीज होगा, बी सी भी इंक्रीज होगा, नथिंग विल डिक्रीज, सी डी भी इंक्रीज होगा. मैं डायमेंशन की बात कर रहा हूं, अदर क्वांटिटीज नहीं, वॉल्यूम तो डिक्रीज होगा. तो थिंक अबाउट दिस, AT is at higher temperature, तो AT must be, think about it, AT must be greater than A naught, or we can say A naught is less than AT. Think about this, BT is also at high temperature, so B naught is also less than BT. These are the two options. We can conclude here, AT, A naught is less AT, correct. B naught is greater, ये तो possible नहीं है. A naught is less, B naught is less, and the density of disk increases. वैसे मुझे ये correct लग रहा है. अब think about this part, second part. ये wrong हो गया. A naught is less, B naught is less, but density increases, decreases. ये भी correct है, ये वाला correct है, ये वाला correct है, और ये wrong हो गया. A naught is less, B naught is greater, तो ये भी wrong हो गया. अब think about density. डेंसिटी के पर्पज से मेरा ये वाला करेक्ट लग रहा है, ये करेक्ट लग रहा है, लेकिन थिंक अबाउट डेंसिटी, यू नो वेरी वेल डेंसिटी dt इज इक्वल टू, या सपोज कीजिए d इज इक्वल टू m अपॉन v. इफ बी increase the temperature, then v volume will increase, no change in mass. So on changing temperature, its density will decrease because v will increase volume. तो अब देखिए यार डेंसिटी इंक्रीज है, नॉट पॉसिबल, तो ये वाला करेक्ट लग रहा है. तो करेक्ट आंसर इज सी, A is less than AT, B is less than BT, and density of the disk decreases because its volume on increase the temperature will increase, so density will decrease. So correct option is C. It is also important question. Now the next question is, now these are the subjective questions. Water is the question number 11, part A, subjective question. Water falls from a waterfall from a height of 100 meter. ये देखिए यहाँ से, at the waterfall is the base bottom, at the bottom its height is given how much, 100 meter is given. Now water falls from this height 100 meter, find the change in temperature at the bottom of the waterfall we have to change in temperature. यहाँ जो भी temperature था यहाँ भी है, we have to find the difference between the change in temperature. तो we know very well that heat taken or heat converted, there must be mass. तो मैं मान लेता हूँ mass here is m mass, इस height तक गिरेगा. तो all the potential energy when it will reach here converted into kinetic energy, this kinetic energy converted into heat. देखो at bottom all kinetic energy of water, okay, will convert into heat. But kinetic energy कहाँ से आया? हाफ एम बी स्क्वायर दैट इक्वल टू एम जी एच. यहाँ तब था पोटेंशियल एनर्जी एम जी एच, यहाँ तक आया पोटेंशियल एनर्जी जीरो. इट इज कन्वर्टेड इनटू काइनेटिक एनर्जी. सो वी कैन राइट एम जी एच विल बी इक्वल टू एम एस डेल्टा थीटा. डेल्टा थीटा इज चेंज इन टेम्परेचर. अब प्रॉब्लम हो सकती है टू पुट द वैल्यू ऑफ एस. याद रखना ऑल द क्वांटिटीज मस्ट बी इन एस आई. आप सीजीएस में कैलकुलेट किए ही मत, जब तक पूछा नहीं जाए तब तक कैलकुलेट नहीं करें सीजीएस में. ऑल द कैलकुलेशन मस्ट बी इन एस आई. एम से एम कैंसिल, देयर इज नो नीड ऑफ मास. तो जी इज 10, इट इज ऑल्सो गिवन 100. दैट नो यू नो वेरी वेल व्हाट इज द स्पेसिफिक हीट ऑफ वाटर, that is 4200 joule per kilogram, or delta theta is to be find. So what is delta theta? 1000 divided by 4200, that is 4200. It is cancel. It is 1 upon 4.2 is the value of J, that is 0.24 degree Celsius. Change in temperature. Change in temperature, that is equal to 0.24 degree Celsius. अब आप कहेंगे इतनी जल्दी डिवाइड कैसे किया? तो you know very well J is 4.2 and 1 upon J is 1 upon 4.2, that is how much? 0.24. remember it. और सबसे ज्यादा मिस्टेक हो सकती है टू पुट द वैल्यू ऑफ एस. एस मस्ट बी इन एस आई. वैसे हम जानते हैं वाटर की एस होता है वाटर का 1 कैलोरी पर ग्राम इंटू डिग्री सेल्सियस, और सेम थिंग दैट इज 1000 कैलोरी पर किलोग्राम इंटू डिग्री सेल्सियस. We want to convert into joule and multiplied by 4.2. You can easily find it. पर किलोग्राम लिखा है तो 42, इसलिए मैंने ये वैल्यू पुट की थी 4200 जूल पर किलोग्राम इंटू डिग्री सेल्सियस. तो दिस वाज द आंसर ऑफ पार्ट ए, क्वेश्चन नंबर 11. नाउ द नेक्स्ट क्वेश्चन इज सेकंड पार्ट ऑफ दिस क्वेश्चन, दैट इज क्वेश्चन नंबर 11 बी पार्ट. 3 liquids with masses m1, m2 and m3 are thoroughly mixed. Their specific heats are C1, C2 and C3 respectively. Their temperatures are T1, T2 and T3. Find the temperature of mixture. Okay, we don't know which temperature is higher, which is at lower. So most important method is this one. Suppose all liquids first goes to 0 degree Celsius. हर मिक्सचर, हर लिक्विड 0 डिग्री सेल्सियस में मूव कर रहा है. देन द हीट गिवन बाय ऑल लिक्विड्स सपोज Q1, that is equals to, think about first mass is m1, specific C1, change in temperature from T1 to 0, so T1 minus 0 by second m2 C2, temperature T2 minus 0 by third is m3 C3, T3 minus 0, It's the heat given when all the liquids move from T1, T2, T3 up to 0 degree Celsius. Now this heat is liberated. All the liquids will give this heat. Due to this heat, the temperature of each liquid will move. Suppose final temperature is T डिग्री सेल्सियस. तो देखिए जीरो वाला फर्स्ट भी T पर जाएगा, ये जीरो वाला भी T पर जाएगा, ये जीरो वाला भी. नाउ ऑल द लिक्विड्स आर एट 0 डिग्री सेल्सियस. देन हीट यूज्ड that is Q2 is equals to by first liquid M1 C1 into T minus 0 plus M2 C2 into T minus 0 plus M3 C3 into T minus 0. बट एक्स्ट्रा हीट तो कहीं मिल ही नहीं रही मुझे, केवल ये हीट लिबरेट हुई थी जब वो 0 डिग्री पर आए थे. अब उनका टेम्परेचर 0 से इंक्रीज हुआ T तक, ऑल का सबका लिक्विड का सेम ही होगा Q2 because of Q1 is equals to Q2. Put the value of Q1 and Q2, find the value of T, that will be M1 C1 T1 plus M2 C2 T2 plus M3 C3 and T3 divided by M1 C1 plus M2 C2 plus M3 C3. It is the answer. Final temperature is this. सबसे पहले सारे लिक्विड्स को मैं 0 पर लाया, 0 से फाइनल टेम्परेचर पर ले गया, तो 0 पर लाऊंगा तो हीट लिबरेट करेंगे, निकलेगी हीट, और जब 0 से T पर जाएगा तो हीट ये गेन करेंगे, तो इट द फाइनल टेम्परेचर, द फाइनल टेम्परेचर ऑफ द ईच लिक्विड दैट T. तो इट द आंसर. नाउ द नेक्स्ट क्वेश्चन इज, सपोज इट द लास्ट क्वेश्चन. एंटीपायरेन इज गिवन टू ए बॉडी ऑफ सफरिंग फ्रॉम फीवर. ये इंपॉर्टेंट क्वेश्चन है. देखिए जनरली हमको टेम्परेचर होता है तो टैबलेट देते हैं. क्या होता है टैबलेट से? टैबलेट से क्या होगा, कुछ हमारा जो वाटर है, बॉडी का वाटर, वो एवोपरेट हो रहता है, और एवोपरेट होगा तो एवोपरेट होने के लिए हीट चाहिए, वो हमारी बॉडी से हीट लेता है, और हीट लेगा तो टेम्परेचर डाउन होगा बॉडी का. तो दिस इज द फंक्शन ऑफ दिस एंटीपायरेन, ड्यू टू विच हमारी बॉडी का कुछ वाटर एवोपरेट हो जाएगा. एवोपरेशन के लिए जो हीट यूज होगी वो बॉडी की होगी, और बॉडी की होगी उसका टेम्परेचर डाउन होगा. तो एंटीपायरेन इज गिवन टू ए बॉय सफरिंग फ्रॉम फीवर 101 डिग्री फ़ारेनहाइट. रिमेंबर यू हैव टू कैलकुलेट इन SI. सेल्सियस में रखिए या केल्विन में रखिए? सेल्सियस में रखेंगे, बिकॉज देयर इज नो चेंज इन केल्विन एंड सेल्सियस व्हेन वी विल टेक द चेंज इन टेम्परेचर. मैं आपको एक एग्जांपल बता दूं. चेंज इन टेम्परेचर is 30 degree Celsius, तो same will also be 30 Kelvin, because change in temperature there is no difference between Kelvin and Celsius. Now think about this. Evaporation of water from his body increases. If in 20 minutes the temperature fall to 90 degree, it is Fahrenheit, not Celsius. Fahrenheit by Celsius में तो बॉडी बॉयल होने लगेगी. Okay, it is Fahrenheit. Then what will be the extra evaporation rate due to the medicine given mass of the boy is, देखो mass of solution, mass of boy that is equal to 30 kilogram. It is given. Change in temperature, that is equals to 101 minus 90, it is 98. Remember it, 8 degree Fahrenheit. 90 पे आ जाएगा बॉडी तो प्रॉब्लम हो जाएगी. 98 डिग्री फ़ारेनहाइट. ओके 98, दैट इज 98. भाई 90 पे नहीं पहुंच सकती थी, आप जानते हैं ना, ठंडा हो जाएगी बॉडी. It is how much? 2 and 3 degree Fahrenheit. But we have to use in Celsius. So 3 into, you know or not, 5/9 Fahrenheit को convert करना है. You know very well or not? 5 by 9, that is 3 times, that is how much? 5 by 3 degrees Celsius. It is a change in temperature, delta T is given. Now remember this one, 98 degree Fahrenheit है फाइनल टेम्परेचर, नॉर्मल टेम्परेचर, और ये जब टेम्परेचर होता है तब इंक्रीज होता है 98 से. ओके, एक्स्ट्रा ऑपरेशन, इतना हीट आप बता सकते हैं व्हाट इज द हीट जब बॉडी 101 से 98 पर आएगी, तो व्हाट इज द हीट गिवन बाय द बॉडी, हीट गिवन बाय द बॉडी. मैं क्यू लिख सकता हूं, Q इज इक्वल्स टू एम एस एंड डेल्टा टी. एम इज गिवन 30, एस लिखा हुआ है हीट ऑफ ह्यूमन बॉडी, ह्यूमन बॉडी इक्वल टू द वाटर ऑफ वाटर. हीट मीन्स स्पेसिफिक हीट, इट इज 4200 and delta T is also given 5 by 3. We can change it, calculate is 5 by 3. Okay. Also given, that is 4200. If you want to calculate in calorie, then it must be not kilo, to find divide by J. Divide by J means 4.2. 4.2. अगर ऐसा नहीं कर सकते हैं तो put here only 10 raised to the power 3 calorie per kilogram. S is 10 raised to the 3 calorie per kilogram into degree Celsius. So we can, this one, that is what is the Q is equals to 3 cancel, that is 10 time, that is 10 raised to the power 4, it's cancel 3, that is 5 into 10 raised to the power 3 and 4 calorie. And the heat given by the body, due to this heat some water of our body will evaporate. तो कितना evaporate होगा? Water evaporate के लिए you know very well the latent heat of vaporization. Latent heat of vaporization, what is the value of latent heat of vaporization? Latent heat of vaporization is given 580 कैलोरी पर ग्राम. अब याद रखिए मास हमने किलोग्राम में लिया है, तो 580 कैलोरी पर किलोग्राम निकालना है. तो एल बी इज टू 580 इंटू 10 raised to the power 3 कैलोरी पर किलोग्राम एट द लेटेंट हीट पर किलोग्राम. तो वी कैन कैलकुलेट इतनी हीट से कितना वाटर एवोपरेट होगा. वी कैन इजीली फाइंड द मास ऑफ वाटर बिकॉज Q is divided by this heat. So 5 into 10 raised to the power 4, that is mass evaporated. किसका? वाटर का. कितना वाटर एवोपरेट हुआ? दैट इक्वल टू हीट Q अपॉन LV. Q is given 5 into 10 raised to the power 4 और it is 580 into 10 raised to the power 3. Is clear? ये कैंसिल, that is how much? 5 by 58 किलोग्राम. इतना मास एट द एम, इतना मास वाटर का एवोपरेट होगा एट द मास. इफ यू वांट टू कन्वर्ट इन ग्राम देन मास विल बी, आपको क्या फाइंड करना देखिए. हीट ह्यूमन बॉडी इज वाटर, लेटेंट हीट ऑफ वाटर इज दिस वन. तो एक्स्ट्रा गिवन है इसमें व्हाट द फॉल दिस हीट ह्यूमन बॉडी इज इक्वल टू दैट ऑफ वाटर. ओके, तो यू हैव टू फाइंड, टाइम इज गिवन 20 मिनट. एक्स्ट्रा रेट क्या होगा? एवोपरेशन रेट. तो थिंक अबाउट इट. मास इज दिस वन, वी कैन कन्वर्ट इनटू ग्राम आल्सो. तो रेट ऑफ एवोपरेशन that is equal to m upon time. Mass is given how much? 5 by 58 into 20 per minute, that is kilogram per minute.